So we can really load up these equations on the left side with this absolute value sign here. So in this particular, and this is going to be our final example, in this particular one, we have a lot of things going on in this equation. We have 2 plus 5 times the absolute value of 10 plus 5x is equal to 32. It's in no shape right now to draw a picture because we have too many things around the absolute value symbol. I'm going to start by showing you my favorite mistake that students make on this problem. My absolute favorite mistake that gets made is they look at the 2 and the 5 and they say, oh, I'm just going to combine the 2 and 5 and get 7. And it really looks like you could do that. Like, why not? 2 plus 5 is equal to 7. So you get 7 times the absolute value of 10 plus 5x equals 32. There's a problem, a major problem there. And that is this 5 right here is held together to the 10 plus 5x by multiplication. So we're going to have to deal with that first before we can just simply combine the 2 plus 5. Think about it this way. If this were 2 plus 5x, would that give you 7x? And the answer is no, it wouldn't. So that cannot be done. So that's my favorite mistake. So what should we do instead? Well, what we're going to do is go ahead and get that 2 out of there. So we're going to subtract a 2 from both sides, and that gives me 5 times the absolute value of 10 plus 5x equals 30. And here comes my second favorite mistake. My second favorite mistake is when students treat the absolute value signs like parentheses. So they say, well, I'm just going to go ahead and distribute the 5 to the 10 plus 5x. If this were a set of parentheses, you could do that and it would be perfectly legal. But it's not parentheses, it's absolute value signs. And so there's a variety of reasons of why you cannot do that. I'm not going to get into this in this video, but I'm going to tell you, do not treat absolute value symbols as parentheses because they mean very different things in mathematics. Okay, so having said all that, how the heck do we solve this problem? Well, we're going to go ahead and subtract the 2 from both sides. And then instead of multiplying everything by 5, I'm going to go ahead and divide both sides of the equation by 5. And when I divide both sides of the equation by 5, I get 10 plus 5x equal the absolute value of 10 plus 5x equals 6. But we know addition is not a very good way to indicate distance on a number line. So we're going to change that addition sign to 10 minus a negative 5x equals 6. And by this point in time, I'm assuming that you're pretty comfortable at drawing pictures for these. And you might even start to be able to do this stuff in your head or have a picture drawn in your head, which would be great. If not, you can still draw a picture. That would be okay. In this case, I'm not going to draw the picture, but instead I'm going to tell you that when I start at 10 and I subtract a distance of 6, that's going to give me negative 5x. So negative 5x equals 4. Divide by negative 5, I get x equals negative 4/5. It's not a nice answer as far as integers, but it is an answer nonetheless. And if you were to plug that negative 4/5 back in for x, you would see that it works. On the other hand, if I start at 10 and I add a distance of 6 to that, that's going to also give me a negative 5x. So I get negative 5x equals 16. Go ahead and divide by negative 5, and I'm going to get x equals negative 16/5. And you can either go back and test these values to make sure that they work. I'm going to tell you that they do, but it wouldn't be a bad exercise for you to test those. And that's how you solve a pretty complicated absolute value equation.